Hi there, we're back with the second equation here, and this should look a little bit funky to you, but this is also function notation. This is g such that x represents, with respect to x, represents this function. So this is right here another fancy way to just say g of x equals negative 2 x plus 1 squared plus 8. And this form right here is known as vertex form. And vertex form is just a x minus h squared plus k, where h and k are your vertex. Named because it's easy to identify our vertex. So I'm going to start off the big four with my vertex here. Vertex being the positive makes it a negative 1, comma 8. From that, I can easily find my line of symmetry, which is just negative 1. We'll start graphing this over here so we have an idea of what our sketch looks like. So we have our vertex at negative 1, 8, 1, 2, 3, 4, 5, 6, 7, 8. Line of symmetry here at negative 1. So I'll put in my line of symmetry at negative 1. And then we'll go ahead and start solving. I like to always do my y-intercept first. So that's when x is equal to 0. So I do y equals negative 2, 0 plus 1 squared plus 8. Which gives me 1 squared times negative 2. And that coordinate point would be 0, 6. 1, 2, 3, 4, 5, 6. And if this is my line of symmetry and I'm 1 unit away here, I know that I'm going to have a brother from another mother over here. Then we'll do the x-intercepts, which is when y is equal to 0, and this one's a little bit fun to solve here. We have y equals negative 2, x plus 1 squared plus 8. So I'll move my 8 over. So I have negative 8 equals negative 2, x plus 1 squared. Divide both sides by negative 2, gives me 4, x plus 1 squared. To undo that square, now if I have a square of a variable, that means that variable can be positive or negative. So I could have a 2 equals x plus 1, or I could have a negative 2 equals x plus 1. So then minus 1 from both sides, 1 equals x. There's one x-intercept, and the other one, minus 1 from both sides, negative 3. So that gives me the point 1, 0, negative 3, 0. So here is 1, 0, 1, 2 units away, 1, 2 units away, and that is the sketch. Hopefully yours looks a little bit better than mine of the quadratic. Go through the same thing with the graphing calculator. I'm not going to do it on the videos, but I would like you to practice finding all these key concepts with the graphing calculator once again. We'll move on to the last one. Here, this is the famous standard form, so it is in the form ax squared plus bx plus c. The easiest thing to identify from this form is your y-intercept. So when x is equal to 0, this term goes away, that term goes away, and our y-intercept is known as our c value, which is just 6. So that's the coordinate point 0, 6. I'll start graphing this right away so that we can have an idea of what our sketch is going to look like. So we're at 0, 6. 1, 2, 3, 4, 5, 6. All right, from here, we can find our x-intercepts by setting y equal to 0 and solving for x. So I could have 0 equals negative 2x squared minus 4x plus 6. I'm going to try to factor this so I can use a 0 property. So I will factor out a -2 first, my greatest common factor. So that leaves me with x squared plus 2x minus 3, and then I can factor x plus 3, x minus 1, and I can use my zero property. First I'll divide both sides by the -2, it's one fraction. So I have x plus 3, x minus 3, and the zero property just states x plus 3 has to be 0 or x minus 1 has to be 0. So x is -3 or 1. So -3, 0, 1, 0. So here's 1, 0, 1, 2, 3, -3, 0. We'll move on to finding our line of symmetry, which is -b over 2a. Our -b here is -4, 2 over -2. So that gives us a +4 over a -4, which is -1. I'll draw in my line of symmetry. Then to find the vertex, this problem's looking a little bit familiar. We will put in -1 into this whole expression. I'll keep it red here. So we need to find h of -1. So that's -2 times -1 squared minus 4 times -1 plus 6. So this becomes -2 plus 4 plus 6, which is 2 plus 6, 8. So we have a -1, 8. So 6. There is our vertex and quadratic. Check that with your graphing calculator. Make sure that you're familiar how to use the graphing calculator so that you're ready for the exam that's part calculator and non-calc.